Very good morning. Today we are going to demonstrate how to rig up connection for this Boolean expression using basic gates, using NAND gates only, using NOT gates only. And for this particular Boolean expression, this is the truth table. So if you observe here, there are three variables A, B and C. As a result, within the truth table you will get 8 different combinations, and we have one product term B into C. So here this is the B column, this is C column. If you multiply this into this, you will get the new column, that is B into C column, and this is your final output, which is A, that is addition of Boolean addition of this column as well as this column. Say for example 0, if you add with 0 you will get 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, something like that. Now this is the expression A plus B into C. In order to get output for B into C, I need one AND gate, which can be obtained through 7408 IC. And in order to get this plus, I need one OR gate, and the corresponding IC for OR gate is 7432. Now once you write a logic diagram for this particular Boolean expression, you will get a logic diagram which will look something like this. And these are the pin numbers for 7408 IC. That is pin number 1 here, 2 here and 3 here. For OR gate, here it is pin number 1, here it is pin number 2 and here it is pin number 3. There are 3 actual inputs. They are A, B and C, and you have only one actual output wherein you will get the output. Here we will vary the input using 3 different combinations, so that you will get 8 different combinations, and finally we will measure output here. Now we will see how to make connection for this particular logic diagram using digital IC trainer kit. Now we will show that. First, what we will do is we need to select 7408 as well as 7432 IC. Here we have placed 7408 and here we have placed 7432 IC. As I already mentioned, for these two IC we should first give supply voltage. In other words, we should connect pin number 14 to VCC. So this is your VCC, this is pin number 14, and we should connect pin number 7 to ground. This is the first connection. Now if you observe here, where pin number 1 has to go, pin number 1 of 7432, pin number 1 of 7432 has to go to A, which is one input. Even for this particular IC, we should give VCC as well as supply voltage. Now if you observe, we have given supply for both these two ICs. That is pin number 14 we have connected to VCC, pin number 7 we have connected to ground. Now we will start with the first connection, that is pin number 1 of 7432, we should connect it to actual input. Say for example, let me consider this as A, which is one actual input. Now pin number 2 of 7432 has to be connected to pin number 3 of 7408. So this is pin number 2 of 7432, right? This is 7408. Here pin number 3 is this one. So for that we should connect. Next, moving on, pin number 1 of 7408 has to be connected to where B, another input. As I already mentioned, blue lines are input. So let me consider this as B. Next, moving on, pin number 2 of 7408 has to be connected to where another input, right? Another actual input, again to blue line. So we completed this. We also completed this part. We were left only with this connection, right? That is pin number 3 of 7432. This is 7432 IC, right? It has to be connected to actual output, that is yellow line. To any of this yellow line you can connect. Now this completes circuit connection for this particular Boolean expression using basic gate. Now we will check the output in digital IC trainer kit and we will verify the truth table. Now first we gave supply to this particular digital IC trainer kit by turning on the switch. Now if you observe, you can observe one light over there, right, when we turn on, which indicates that we are receiving supply. Now we will vary the inputs, that is we will check for all 8 combinations using 3 inputs A, B and C. Initially, now if you observe here, these toggle switches are nearer to you, right? If it is nearer to you, it is like 0, like something like this. If it is away from you, it's like 1, which is indicated by an LED light. Now if you observe here, they are nearer to you. This is A, this is your B and this is your C. They are nearer to you, which indicates that they are all 0. And you can also observe that with help of LED light. None of them are glowing here, right? Neither A nor B or even C is not glowing, which indicates that they are all 0. When all the inputs are 0, that is A0, B0 and C0, what is the output? It is 0, right? Similarly, now we will check for the next combination, that is for 0, 0 and then 1. Now we will see that we will change only input C to high. A0, B0 and C will make 1. See here, now A is 0, B is 0, C is 1. What is the output? It is 0, right? Same as this particular truth table. Now we will check the third combination. The third combination is 0, 1, 0. See here, we made that particular change here in digital IC trainer kit, that is 0, 1, 0. What is the output? No light, right? Which indicates that it is 0. If you observe this particular truth table, it is again 0. Now we will check for the fourth combination, that is for 0, 1, 1. What is the output for 0, 1, 1? It is 1. Now we will check the same over here. See here, 0, 1, 1. Did I get the output? Yes, of course we got the output, which is indicated by LED light, which is high. Similarly, we will proceed to the next combination, that is 1, 0, 0. Now we will make that particular change, that is 1, 0, 0. What is the output? It is 1. Now we will check for the next combination, that is for 1, 0, 1. For that, what is the output? It is again 1. Now we will check for the next combination, that is 1, 1, 0. The output is again 1. Now we will check for the last combination, that is for 1, 1, 1. Again we got output as 1. This is how we will verify the truth table. Hope you have understood. Yeah, hope you have understood how to rig up the connection for the given Boolean expression, that is y is equal to a plus bc, using basic gates. Now we will verify the output for the same Boolean expression y is equal to a plus bc using only NAND gates. And this is the circuit diagram for y is equal to a plus bc using only NAND gates. Now if you observe here, there are 3 NAND gates. Okay, so there are 3 inputs and only 1 output. See, if you observe here, for 7400, pin number 1, 2 should be shorted either from pin 1 or from pin 2. It has to go to A, and B, C are separate inputs. These 2 intermediate output will act as an input for this particular gate, and here we will get the actual output. Now we will see the circuit connection. So as I already mentioned, before you start, we should connect pin number 14 to VCC and pin number 7 to ground. So here I have used 7400. The first connection is pin number 14 to VCC, pin number 7 to ground. Now as I told, pin number 1 and 2 we should short. So we will short that now. So we shorted pin number 1 and 2 either from pin number 1 or from pin number 2. It has to go to where? One of the input, right? A is one input. So here I have considered this as my one of the input, which is A. Now we will connect pin number 4 to another input. See, this is pin number 4 which I connected to another input, and I'll call this as input B. Now I'll use pin number 5. Pin number 5 I'll connect to where? Another input, that is C. So I consider this as C. Now, where pin number 3 has to go? Pin number 3 has to be connected to pin number 9. See, this is pin number 3, this is 7, this will become 8, and this will become your 9, right? So, I should connect pin number 3 to 9. Hope you have understood this. And where pin number 6 has to be connected? See, this is pin number 6, it has to be connected to pin number 10. If this is 7, this will be a 8, 9, and this will be a 10. Okay, and pin number 8, if this is 7, this will be a 8. Pin number 8 has to be connected to where? Y, which is your actual output. So yellow lines will give you the output, right? So we selected this as our actual output. Now we will turn on the IC trainer kit and we will verify the output. If A, B, C are 0, what is the output? It is 0, which you are observing there. Now we will change our input to 0, 0, 1. If input is 0, 0, 1, output is 0. If it is 0, 1, 0, again your output is 0. If it is 0, 1, 1, output is 1. Now if you observe there, for 0, 1, 1 combination, we are getting output as 1. Next for 1, 0, 0, again output 1, 1, 0, 1, again 1, 1, 1, 0, output is 1, all 1, again output 1. So this is how we will verify the truth table for this particular expression by regrouping the circuit in digital IC trainer kit using only NAND gate. Hope you have understood. Thank you.